Hey everyone, this is going to be our first lesson video for pre-calculus, and before we get started, I just want you all to know that I really do love you and miss you, and I want this to be the best experience for you, and that's why I decided to create these videos. And when I had this idea at the beginning, I just thought, sure, I'll make some videos of me teaching and it will be great. But what I didn't realize is how much work it takes to make one of these videos. I made a 40-minute video just a little while ago, and when I'm playing it back, I'm realizing what a train wreck it was and I couldn't use it. So I'm starting over again and trying to make it better this time. So please be patient with me and realize that I'm a teacher. I'm not a videographer. This is not going to be, some award-winning video, but I do want to convey the information to you and hopefully in a way that you'll understand. So please bear with me. Hopefully I'll get better as time goes with making these videos. Okay, so if you haven't done so yet, please go to my Google Classroom and print off the notes that are titled Solving Trig Equations Part 1. And if you're not able to print them off, at least read through what is there before we get started on the lesson. Another thing you will need is your unit circle. And if you have your own that I gave you in class, that's great. If some of you said you didn't bring your notebook home when we left school, that's okay too. I printed off, or I posted another unit circle for you. So you can print that one off if you'd like instead, or look at that one when you're doing your work. So let's get right to the video so we don't waste much time here. So we're going to be solving trig equations next, and so it's going to involve using some algebra first, and then afterwards using the unit circle. So we're going to do two things in each problem. So I'm going to get my whiteboard ready to show you the problem. So we're going to go through the ones that are in the note sheet. So have your notes and your unit circle handy. Now keep in mind that as we're going through the lesson, you can pause and rewind. You can stop and start it however you like. You can't do that in real life. You can't pause me or rewind me in real life, but the beauty is here you can. So feel free at any moment to pause and catch up. All right, here we go. So I'm going to get my handy dandy whiteboard ready for you. All right, so question number 1 on your sheet is to solve a trig equation. So the equation is 2 sine of x minus 1 equals 0. Okay, and off to the side it says we're going to solve it on the interval negative infinity to infinity. All right, so first of all we're going to use a little algebra and try to isolate the trig expression sine of x. So like we normally do in an algebraic equation, I'm going to look at this minus 1 and add it to the other side. So I would say 2 sine of x equals 1 after it was added over. Then I'm going to take this 2, and since it's multiplied now, I'm going to divide both sides by 2. So I'm going to say that the sine of x equals 1/2. So the algebra part is done. We have the sine of x by itself. From here, we're going to use inverses. So we studied inverses maybe a month or so ago. So what we are doing is trying to find angles on the unit circle whose sine value is positive 1/2. And just as a refresher, if you're looking at your unit circle, it is the y-coordinate that you're looking at. So you will see that one angle that has a sine value of 1/2 is pi over 6. Now, when we were doing inverses in the past, you were restricted to which quadrant you can give an answer in. Not the case here, because it says from negative infinity to infinity. So it can be any angle on the unit circle, not just the ones in certain quadrants. So there is another angle that has a sine value of positive 1/2, and that would be 5 pi over 6. Both of those angles have 1/2 as their sine values. Now, because this equation says we have to solve it over the interval negative infinity to infinity, we would have more than just these two answers, because we could think about going around the unit circle any number of times. So you have to keep in mind that when we were studying sine and graphing a little while ago, that the period for a sine function is 2 pi. So in order to get more possible solutions, you could add 2 pi to pi over 6. You could also subtract 2 pi from pi over 6 and get more solutions. And you can do that any number of times. So we use the variable n to show that we can add or subtract 2 pi any number of times. The same would be true for 5 pi over 6. You could either add or subtract 2 pi any number of times to get more solutions from negative infinity to infinity. So your final answer for number 1 would be this right here. So x would be pi over 6 plus or minus 2 pi n, or 5 pi over 6 plus or minus 2 pi n, and you would need to include both. So remember, you can pause if you need to catch up and restart when you're ready. Okay, so number 2 is 2 tangent of x minus 2 equals 0. And again, it says from negative infinity to infinity. All right, so we're going to first start off with a little bit of algebra. So I'm first going to add the 2 over to the other side. So that would be 2 tangent of x equals 2. I would need to divide both sides by 2. So 2 divided by 2 would be 1. So I'm left with tangent of x equals 1. So the algebra part is done. So now I would go to an inverse. So I would say the inverse tangent of 1. Okay, so now you would need to get out your unit circle. And the tangents are the ones that we wrote by hand in class, or if you're looking at the one that I posted on the page, they're in red, I believe, over to the side. So we're looking for whichever angles have a tangent value of 1. So one angle that has a tangent of 1 is pi over 4. And then there's another one that has a tangent value of 1 in the third quadrant, and that's 5 pi over 4. Both of those have a tangent value of 1. Now, because it says to solve from negative infinity to infinity, these are not the only 2 solutions. We could go around the unit circle multiple times. But the period for a tangent function is not 2 pi, but just pi. We learned that when we were graphing. So you can add or subtract pi any number of times. And for this one, you can also add or subtract pi any number of times. And then this would be the answer for question 2. Now I want you to note that if this had been a cosine equation that was written in the same way, the part over here would have been 2 pi n and 2 pi n, just like for sine. So it says that in the notes up in the paragraph above that tangent has a period of pi and sine and cosine have a period of 2 pi. So that's why you see a difference here. Okay, so on to number 3. Okay, the ones that are past number 2, so from 3 on, they look similar to the other ones that we've done, but there is a slight difference in the question. So if you notice over to the side, instead of just this and then negative infinity to infinity, this one says we're solving from 0 to 2 pi. So that's the difference. So in a little bit of review from algebra, if you see a bracket, that means that 0 is included, and if you see a parentheses, that means 2 pi is not included. So we're going to do the algebra first. I'm going to add the 5 over, so that would be cosine of square root of x, 10 cosine squared x equals 5. And then I'm going to divide by 10, so I would say cosine squared of x is, so 5 divided by 10, 5/10 would reduce to 1/2. Now in algebra, you learn that whenever you see a square and you want to eliminate it, you do the square root of both sides of the equation. So we're going to do that here too. So on the left side, the square root and the square will cancel each other out. And on the right side, we have this radical that has a fraction inside. So 2 things we have to remember. One thing is that if we square root both sides of an equation in algebra, you have to include plus or minus. That applies here too. And then we have to deal with this fraction inside of the radical. So in algebra, you learn to think of the 2 numbers separately, like square root of 1 over square root of 2. The square root of 1 is 1, and the square root of 2 would stay the same. Now you also learned in algebra not to leave the radical in the denominator, so you have to do what is called rationalizing. So you would multiply the top and bottom by square root of 2. And if you multiply straight across, you would get square root of 2 over 2. So you're left with this. Cosine of x equals plus or minus square root of 2 over 2. So the algebra is now done. Now we're going to go to inverses. So we're going to do the inverse cosine square root of 2 over 2. Now this is where, oh, positive or negative. Thank you. Okay. So we're going to look on our unit circle and look for any angle that has a cosine value of either square root of 2 over 2 or negative square root of 2 over 2. Okay. So if you look in quadrant 1, the angle pi over 4, that has a cosine value of square root of 2 over 2. If you go to the second quadrant, 3 pi over 4 has a cosine value of negative square root of 2 over 2. In the third quadrant, 5 pi over 4 has a cosine negative square root of 2 over 2. And in the fourth quadrant, 7 pi over 4 has a cosine value square root of 2 over 2. So all four of these would match this, that the cosine value is either positive or negative square root of 2 over 2. Now this would be the final answer for this question because it's said to only solve between 0 and 2 pi. So you do not put the plus or minus 2 pi in or whatever it is for each of these questions. Only when it says negative infinity to infinity would you do that. So these are the answers between 0 and 2 pi. So that one is done. Remember, you can always pause and restart if I'm going too fast. Okay, so number 4 is the cotangent square root of x minus 3 equals 0. And again, it says to go from 0 to 2 pi. Okay, so we're going to do the algebra part first. So we're going to begin with adding 3 to the other side. Then to eliminate the square, we're going to do the square root of each side. So what would be left with the cotangent of x is, now remember when you square root both sides, you have to include plus or minus. And the square root of 3 cannot be simplified because there's no perfect square that divides into 3. So you would just put plus or minus the square root of 3. Okay, so this one's a little different in that cotangent is one of the reciprocal functions. It's the reciprocal of tangent. So I'm going to change it to a tangent equation. And I would still need plus or minus, but I would want to think, what is the reciprocal of the square root of 3? So it would be 1 over the square root of 3. Then you would need to rationalize it. And if you multiply straight across, you would get plus or minus square root of 3 over 3. Okay, so the algebra is done on that one. So now we would do an inverse. So we're trying to think of the inverse tangent of either positive or negative square root of 3 over 3. So this means you find any angle on the unit circle that has a tangent value of either positive square root of 3 over 3 or negative square root of 3 over 3. So in quadrant 1, you would find that pi over 6 would match that. In quadrant 2, you would find 5 pi over 6. In quadrant 3, 7 pi over 6. And in quadrant 4, 11 pi over 6. So all four of those angles would have a tangent value of either positive square root of 3 over 3 or negative square root of 3 over 3 between 0 and 2 pi. Okay, question 5. Sine of x plus square root of 2 equals negative sine of x. And it still says go from 0 to 2 pi. Okay, so first of all, you would want to use a little bit of algebra. Whenever you had an x on both sides of an equation in the past, you would move them all to the same side. So we're going to do the same thing here. I'm going to add sine of x to both sides. So sine of x plus sine of x would be 2 sine of x. The square root of 2 would still be there. And then this would cancel, so that would be 0. Then I would subtract the square root of 2 over. So that would be 2 sine of x equals negative square root of 2. I would divide both sides by 2. So that would be negative square root of 2 over 2. And then the algebra is done at that point. So you would use an inverse. Oops, not tangent. I was going to write tangent. Okay, inverse sine of negative square root of 2 over 2. So now you would look on your unit circle and think which angles have a sine value of negative square root of 2 over 2. So you would find one in quadrant 3. That would be 5 pi over 4. And one in quadrant 4 would be 7 pi over 4. So those would be your two answers to this question. Between 0 and 2 pi, these are the two angles that have that number as the sine. Okay, number 6. 4 cosine of x equals 0. And again, it says go from 0 to 2 pi. So first of all, we're going to divide both sides by 4. So 0 divided by 4 is still 0. The algebra is done, so now we're going to do an inverse, the inverse cosine of 0. So you're trying to think which angles on the unit circle have a cosine value of 0. So you would find that to be true at pi over 2 and also at 3 pi over 2. Those two angles have a cosine value of 0 between the interval 0 to 2 pi. Okay, so those are the basic types of equations. The next three are a little trickier because they involve a little more thought. So let me get to that. You might see that I've been wearing glasses in all my videos. So what I have found is that I used to only need glasses for looking at fine print, but since I'm looking at the computer every day now, I need my glasses like all the time. So my eyesight is going, and now I need glasses. So you'll probably see me in glasses all the time now. Okay. So here we go. So this one is different in that it is a quadratic equation, but it's not a simple one like back in number 3. This one will involve factoring. So you did factoring back in algebra with x's and so forth, but we just have to include a sign in this one. So keep in mind that factoring is kind of doing FOIL in reverse. If you're going to do FOIL and arrive at 2 sine squared x, one of them would be 2 sine of x and the other one 1 sine of x. Because together, if you multiplied these two, you would get 2 sine squared. So then you have to look at the last number and think -1. What are its factors? 1 and -1 are the only factors. So what if I were to put a -1 here and a +1 here? I'm just trying it to see if this will work. If I were to do the outer part of FOIL, which would be 2 sine of x times 1, that would be +2. And then if I did these two, that would be -1. So +2 minus 1 would be +1. And we needed that to be a negative, so that's not it. So try it the opposite way. Try a plus here and a minus over here and see if that's better. So if I were to do the outside, that would be 2 sine of x times -1, that would be -2. And then the inside would be +1. So -2 plus 1 is -1. That's the one we needed. So it might take just a little bit of trial and error to get it. Okay, so once it is factored, you would then set each equation equal to 0. Okay, so on this one, in order to solve this, you would subtract the 1 and also divide by 2. So you would get sine of x equals -1/2, kind of skipping a step there. And over here, you would add 1. So it's sine of x equals 1. And then we would do an inverse. So we would say the inverse sign of -1/2, and over here the inverse sign of 1. So now we're thinking on the unit circle, which angles have a sine value of -1? So one of them would be 7 pi over 6, and another one would be 11 pi over 6. And on the other one, we would think which angle has a sine value of 1. There's only one angle on the entire unit circle that has a sine value of 1, and that's pi over 2. So this one has 3 solutions: 7 pi over 6, 11 pi over 6, and pi over 2. So what makes that question different is we had to do the factoring back here, and we had 2 equations to solve. Again, you can pause it and restart it anytime you like if you need to catch up. Okay, so that was number 7. Number 8 is next. 5 tangent squared x minus 5 equals 0. And it goes from 0 to 2 pi. Alrighty, so we're going to do the algebra first by adding the 5 over and also dividing by 5. So that would be the tangent squared x equals 5 divided by 5 would be 1. And then I would do the square root on both sides. And remember algebra rules, you put plus or minus anytime you square root both sides of an equation. And the square root of 1 is 1. So now we will take the inverse. So we'll say the inverse tangent of positive or -1. So we're trying to think of any angles on the unit circle whose tangent value is either 1 or -1. So you will find it is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All of those angles have a tangent of either 1 or -1. One more question and then we will be done. So the last question is different than the others in that you'll see that there are 2 trig functions in the equation. And we're not going to be able to solve this equation until we get it into one trig function, sorry. Okay, so this involves using an identity that we talked about before we left for break. So I don't know if you remember this, but I'll remind you. We did Pythagorean identities at the very end, right before we left school, and it's on the very bottom of your identity sheet. Sine squared of x is the same thing as 1 minus cosine squared of x. So I'm going to replace what is here with 1 minus cosine squared x. So the 2 would still be there. Then I'm going to put in 1 minus cosine squared of x, and then the rest of the equation stays the same. This comes from the identity sheet that we were studying before we left. I substituted in a trig identity. Okay, now I'm going to distribute the 2. So of course 2 times 1 is 2, minus 2 times that would be 2 cosine squared of x, plus 3 cosine of x minus 3 equals 0. Okay, I can simplify this a little bit if I combine the 2 at the beginning with the -3 at the end. So that would be -2 cosine squared x plus 3 cosine of x. And then the 2 minus 3 would be -1. Okay, so that's the equation that we're going to be solving. So I'm going to try to factor it like I did in the problem a little bit ago. So think of factoring as foiling in reverse. So in order to get this -2 cosine squared that we need, we can make one of them -2 cosine of x and the other one 1 cosine of x. Together that would make -2 cosine squared. And then we have the -1 at the end. The factors of -1 are 1 and -1. So we have to think, where can we place them so that we would get the +3 that we need. So if I were to put the +1 here and the -1 here, let's see if that would work out. If I do the outside of FOIL, that would be -2 times -1, that's +2. And then on the inside, that would be positive 1. So together, that would be 3. That works. That's the one I wanted. Okay, so now I am going to set them both equal to 0. And solve both of those two equations. So on the first one, I'm going to subtract the 1 and divide by -2. So I would get cosine of x equals, and remember a negative divided by negative is positive, so it would be positive 1/2. And on this one, I would add 1. So cosine of x equals 1. Okay, so then we're trying to think which angles on the unit circle have a cosine value of 1/2, and which one has a cosine value of 1. So let's see. Angles that have a cosine value of positive 1/2 would be pi over 3 in the first quadrant, and 5 pi over 3 in the fourth quadrant. And there's only one angle that has a cosine value of 1, and that would be 0. Now 2 pi also has a cosine value of 1, but remember at the very beginning the interval said 0 to 2 pi. The bracket means we can include 0, which I did, but the parentheses means that I cannot include 2 pi. So that's why I did not put 2 pi as one of the answers. So those 3 are your answers to that question. Okay, so y'all, I know this was a lot to digest at one time. I totally get that, and I will be available for questions. I'm intending to do a Google Meet sometime this week, so I'll announce it on the page when we'll meet, and you'll be able to see me and talk to me, and we can discuss the problems. Or if you don't want to do that, we could do it by text, so you can text or use my Google Voice number. So you can remind, or do the Google Voice number 863-417-9602. So talk to you soon, guys. I do love you, and I'm trying to do my best for you. So please just be patient with me, and I'll get better at this. So talk to you later, y'all. Love you. Bye.